Hi, welcome to our next section, Understanding SELinux Decisions and Logging. In this section we'll see how we could switch SELinux on and off. Then we'll move on to explore about SELinux logging and auditing. At the end we'll dive into getting help with denials. Now we move on to the first video of this section that deals with switching SELinux on and off. In this video we're going to take a look at switching the global SELinux state and switching to permissive mode. We'll also learn to use kernel boot parameters and how to disable SELinux protections for a single service. Finally, we'll understand SELinux aware applications. SELinux supports three major states that it can be in, which are disabled, permissive and enforcing. These states are set in the etc SELinux config file through the SELinux variable. Let's take a look at the current setting. So, I open the terminal and give the file path, which I mentioned just now. As you click enter, you'll get the current. As you can see here, the state is enforcing. When the system init process loads the SELinux policy, the SELinux code checks the state that the administrator has configured. The states are described here. If the state is disabled, then the SELinux code disables further support, booting the system without further activating SELinux. If the state is permissive, then SELinux is active but will not enforce this policy on the system. Instead, any violation against the policy will be reported but remain allowed. This is sometimes called host intrusion detection, as it works in a reporting-only mode. If the state is enforcing, then SELinux is active and will enforce its policy on the system. Violations are reported and also denied. This is sometimes called host intrusion prevention, as it enforces the rules while logging the actions it takes. Now you can use the get-enforce command, which is provided by the lib SELinux utils package in RHEL to get information about the current state of SELinux, as I do it here. So write se status grep mode and click enter. You can see that the mode is enforcing. Next, let's use the command get-enforce and press enter. It's also possible to query the sudo file sysfs SELinux enforce to get similar information. If the file returns 1, then SELinux is in the enforcing mode. If it returns 0, then it's in the permissive mode. As you can see here, the value that's returned is 1, hence it's enforcing mode. If the etc SELinux config file is changed, then the system needs to be rebooted for the changes to take effect. However, if a system has been booted without SELinux support, re-enabling SELinux support alone will not suffice. The administrator will need to make sure that the files on the system are relabeled. Without SELinux support, Linux will create and update files without updating or setting the SELinux labels on those files. When the system is later rebooted with SELinux support, SELinux will not have any knowledge of the context of a file unless the labels are reset. Now let's look into switching to permissive or enforcing mode. Most distribution-provided kernels allow switching between enforcing and permissive mode through a simple administrative command. This feature is called the SELinux development mode, and is set through the config security SELinux develop kernel configuration parameter. Although this can be considered a risk, switching the mode requires strong administrative privileges, which most application domains don't have. The command to switch between permissive mode and enforcing mode is the set-enforce command, which is part of the SELinux utils package in RHEL. It takes a single argument, 0 for permissive or 1 for enforcing. The strings permissive and enforcing are allowed by the command as well. The change takes effect immediately. For instance, let's use the command to switch to permissive mode. The effect of set-enforce is the same as writing the right integer value into the sysfs SELinux enforce sudo file. Let's see this. The ability to switch between permissive and enforcing mode can be of interest for policy developers or system administrators who are modifying the system to use SELinux properly. It can also be used to quickly verify whether an application warning or error is due to SELinux controls or not, assuming the application is not SELinux aware, which we'll see later. On production systems, it might be of interest to disable the ability to switch to permissive mode. Disabling this feature usually requires rebuilding the Linux kernel, but SELinux policy developers have also thought of a different way to disallow users from toggling the SELinux state. The privileges that users need to switch to permissive mode are conditional, and the system administrators can easily toggle this disabled switching back from enforcing mode to permissive mode. The conditional is implemented through an SELinux boolean called secure mode policy load, whose default value is off. SELinux booleans are configurable options that take on a single value and manipulate parts of the active SELinux policy. The value of the conditionals can be persisted or be kept only during the current boot session. To persist the value across reboots, add -p to the SEBool command, which is part of the policy core utils package, and use to toggle it. So, let's try it now. To get an overview of the available SELinux booleans along with a small description of what they control, use semanage boolean as I did it here. So here's the output. The semanage command is part of the policy core utils Python package in RHEL. The use of the secure mode policy load SELinux boolean allows administrators to restrict switching from enforcing mode back to permissive. However, switching to or from the disabled state is not supported. If SELinux is active and its policy is loaded, then only a reboot can effectively disable SELinux again. Now let's look into using kernel boot parameters. Using the setEnforce command makes sense when we want to switch to the passive or enforcing mode at a point in time when we have interactive access to the system. But what if we need to do this on system boot? If the system refuses to boot properly due to SELinux controls, we cannot edit the etc. SELinux config file. Luckily, we can change the SELinux state through other means as well. The solution is to use kernel boot parameters. We can boot a Linux system with one or two parameters that take precedence over the etc SELinux config setting. In this way, for SELinux is equal to 0, informs the system to disable SELinux completely, and has the same effect as setting SELinux is equal to disabled in the config file. When set, the other parameter which is enforcing is not consulted. Please remember that booting a system with SELinux disabled means that to enable it again, the file system must be relabeled completely. Next, you can set enforcing is equal to 0. This informs the system to run SELinux in the permissive mode, and has the same effect as setting SELinux is equal to permissive in the config file. Lastly, enforcing is equal to 1 informs the system to run SELinux in the enforcing mode, and has the same effect as setting SELinux is equal to enforcing in the config file. Now let's consider a Linux system that uses grub2 as its bootloader. We want to add enforcing is equal to 0 to the boot entry. This can be accomplished during boot with a few steps. First, you need to reboot the system until the grub2 boot screen comes up. So, let me reboot my system. Oops, I missed something in the command. Let's try it again. Now, navigate with the arrow keys to the boot entry for which the SELinux state has to be altered. This is usually the default boot entry and is already selected. Next, press the E key to edit the boot entry line. Do this before grub2 timer reaches 0, otherwise the system will continue to boot. Then, use the arrow keys to go to the end of the line that starts with Linux, Linux 16 or Linux EFI. After this, add enforcing is equal to 0 to the end of this line. Lastly, press Ctrl+X or F10 to boot the entry. Other bootloaders have similar approaches to changing the boot line without persisting it for every reboot. Consult your distribution documentation for more details. Support for the SELinux is equal to boot parameters is enabled through a kernel configuration parameter, config security SELinux boot PAM. The enforcing is equal to boot parameter is supported through the config security SELinux developer configuration parameter, which we've already encountered. When using SELinux in production, it might be wise to either disable the options or properly protect the boot menu, for instance by password protecting the menu, and regularly verifying the integrity of the boot menu files. So, let me sign in. Cool. Next, we move on to disabling SELinux protections for a single service. Since policy version 23, which came with Linux 2.6.26, SELinux also supports a more granular approach to switching between permissive and enforcing mode, the use of permissive domains. As mentioned before, a domain is a term that SELinux uses for types assigned to processes. With permissive domains, we can mark one particular domain as being permissive even though the rest of the system is still running in enforcing mode. To make a domain permissive, we use the semanage command. let's use it right now. SELinux permissive -a -d-lna_t and enter. With the same SELinux command, we can list the currently defined permissive domains. On our HEL, a number of domains will, by default, run in the permissive mode, since that is part of their policy development lifecycle approach. Let's type SELinux permissive -l and enter. So, here's the list of permissive domains. Another method for listing the custom permissive types, those not marked as permissive through the distribution, is to use the SEModule command. In the previous section, we briefly touched on this command when talking about SELinux policy modules. We can use it to list the SELinux policy modules that have permissive _ in their name. Because the SEManage permissive command will actually generate a small SELinux policy module in which the domain is marked as permissive. Let's use the command for it. SEModule -l grep permissive _ and enter. So, this is the output. To remove the permissive mode from the domain, pass the -d argument to the SEManage command. This is only possible for domains that were marked as permissive by the administrator through the distribution provided. Permissive domains cannot be switched to enforcing through this approach. So, let's pass this argument. SEManage permissive -d mini -d-l-na_t and enter. Cool. When a domain is marked as permissive, the application should behave as if SELinux is not enabled on the system, making it easier for us to find out whether SELinux really is the cause of a permission issue. Note, though, that other domains, including those that interact with a permissive domain, are themselves still governed and enforced through the SELinux access controls. Let's step ahead to understand SELinux-aware applications. Most applications themselves do not have a knowledge that they're running on an SELinux-enabled system. When that is the case, permissive mode truly means that the application behaves as if SELinux was not enabled to begin with. However, some applications actively call SELinux code. These applications can be called SELinux-aware, because they change their behavior based on the SELinux-related information available. Such applications change their behavior when SELinux is enabled. We can find out whether an application is SELinux aware by checking if the application is dynamically linked with the lib SELinux library. This can be done with read, elf, or ldd. So, let's do it right now. And now we use the next command. Knowing whether an application is SELinux aware or not can help in troubleshooting failures. In this video, we've learned how to switch SELinux on and off.